In this session, we'll be using data at a variety of scales to identify the at-risk academic programs, courses, and students through the Autoscholar Advisor system. We will describe the metrics that are used as indicators for at-risk performance and go on to the auto-generated advising that can be applied. Let's look at the student profile at UKZN. The average student is about 22 years old and speaks isiZulu as a home language. Almost all students come from South Africa, with just about 1% from Zimbabwe and 1% from Nigeria. We can view the race and gender distribution among the 4 colleges. Between the 3- and 4-year programs, the proportion of students who finish in minimum time is much higher in the 4-year programs. During lockdown, the uploading of online content has really surged, together with the access levels by students. We still find that the majority of the access is through cell phones rather than through desktops or tablets. Now let's look at performance across the institution among the best and worst performing academic programs. We use 2 metrics, namely the graduation rate, or fraction of a cohort that graduates after 3 years, and the minimum rate, or the fraction of a cohort that graduates in minimum time. So these are averages of all students across a whole program. We then plot these metrics against some biographical parameters mentioned earlier. We can see significant correlations with matric results, quintile, gender, and race. However, instead of trying to guesstimate this graphically, we can compute the Pearson R coefficient, which is more clearly the level of correlation. Values close to 1 indicate a strong positive correlation, values close to -1 indicate a strong inverse correlation, and values close to 0 imply no correlation or a complete scatter. We typically accept values more than 0.4 or less than -0.4 as being significant, so we can see some strong indicators here. From looking at this table, it is interesting that the quintile has a strong inverse relationship, while the matric aggregate shows a good correlation. According to this, students from economically disadvantaged backgrounds, but who still achieved good results in school, will outperform their peers. Further to performance, let's unpack our estimate of the worst and best performing academic programs. We specify a criterion like graduation rate and load up the ranked list of all programs across the university. Scrolling through, we can see that in this academic program, from an initial group of 101 students, only 15 graduate in minimum time and only 30 graduate in minimum time plus 1. 55 students have still not graduated, and the majority of these will have dropped out by now. We'd like to understand why this is. Let's go over to the courses at risk view and enter this program code. The system generates a list of at-risk courses. The metric being used here is the number of attempts by students required to pass this course. In other words, the system is counting the number of times that students are registering for a course before they actually pass it. This is one of the chief metrics for this kind of estimation. Furthermore, it determines the number of students taking that course and then classifies the course as being core, core elective, or free elective. Core courses with many attempts needed before passing, which are prerequisites to later courses, are therefore serious impediments to student progression. We can also understand the impact that the presence of such courses have. The system generates a list of so-called impacted courses, and the chief metric here is the difference between the first academic year of study of a course and the academic year of study where it should have been taken. For example, this course has a high pass rate, but is only attempted for the first time on average in the 5th year of study, which is not supposed to exist. It has been impacted by a prerequisite being a gatekeeper course. So let's go back to the gatekeepers and unpack some detail. This section shows which students are at risk of failure in a course. It does this by comparing each student against the mean mark of each assessment in the course and calculating how many standard deviations the students are away from this mean. This is the main metric in this case. Looking just at the mean mark among the assessments, we can see that there is inconsistent performance in this course. Typical means are between 60 and 70%. Let's also get a sense for the types of students here. These students were on average strong performers in the matric and don't seem to have preparedness issues. We can also view the performance by students in earlier coursework. We therefore conclude that this is a gatekeeper due to general issues with this course, and some revision is needed on the program side to ameliorate this issue. Correct identification of gatekeeper courses is a powerful means of improving overall performance. Now let's look at the student side at a non-gatekeeper course. We can see that this course has means that are more usual. Please note here that for this presentation, we've turned on anonymization to protect the student identities. These are hashes of the names and student numbers. We can see that the system provides a summary of concerning areas in this course. If we click on a student's entry, we can also see various biographical detail about the students, so we get some context. Once the students are identified as being in need of support, a lecturer can reach out to a student through an auto-generated email to express concern and to invite counseling. Independent to this, the student may also undertake their own troubleshooting of their performance issues. For non-academic issues that come up, the lecturer or student can also engage with counseling. The majority of the AutoScholar resides in these other areas for AI-supported counseling and helping students through automated training and testing. On this slide, we summarize the various scales of operation needed to identify all the challenge areas from the scale of the whole institution down to the level of individual students. The metrics in each case is shown. Overall then, to really improve performance in a significant way, a multi-scale approach is needed.